So let's take a look at an example that will illustrate what we mean by a sampling distribution. Remember, the sampling distribution is the possible values that can arise from a random process. It is the distribution that happens when we are sampling. As our simple example, let's roll a die. What are the things that could happen when we roll a single die? Well, let's do it lots and lots and lots and lots and lots and lots and lots of times and graph the outcome. Not surprisingly, we could get a 1, 2, 3, 4, 5, or 6 with pretty much equal frequency. This picture is the sampling distribution from one die roll. But wait, there's more. Suppose we were to roll 3 dice. Once again, we'll roll 3 dice, we'll average the 3 numbers from those 3 dice, we'll repeat it many, 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 many times, and here are the possibilities. We could get an average of 1 from those 3 dice, but that's pretty rare because we'd have to roll 3 different ones. Similarly, we could get an average of 6, but again, it's pretty rare because we'd have to roll 3 6s to do so. Averages somewhere between 3 and 4 are the most common occurrences. Averages of 2 are relatively rare, but are about as common as averages of 5. But wait, there's more. If we roll 5 dice, contain your excitement. Now here's our picture. It's very hard now to get an average of 1 or 6 because we'd have to roll 5 1s or 5 6s. More of a chance of winding up between 3 and 4. If we make it 12 dice, contain your excitement, these are the possibilities. It's not completely impossible to get an average of 1 after 12 die rolls, or an average of 6, but it's pretty close to it. In fact, averages of 5 or more, or 2 or less, would still be pretty uncommon under those circumstances. And the overwhelming majority of the time are going to be somewhere around 3.5. Notice what's happened. We started off by rolling 1 die. Those are the possibilities. We roll 3 dice. These are the possibilities. If we roll 5 dice, those are the possible outcomes for averages. If we roll 12 dice, those are the possible outcomes for averages. 2 things are happening in this sequence of pictures. One is, to use a technical term, things are smushing up. We've got a lot of variability, a lot of spread outness in this first picture. As we move down, as our sample size gets bigger, it becomes harder and harder to be out at the extremes, and more of the data are towards the middle. Things are smushing up. The other thing that's happening is that things are belling up. We start off with something that is in no way a bell curve. But as our sample size gets bigger, we get closer and closer and closer to our bell curve, to our normal distribution. Things are smushing up, things are belling up. Those are the 2 key points to remember from this demonstration. As we look at sampling distributions, as the sample size increases, things smush up, things bell up. In the next video, we'll be a little bit more technical in terms of terminology, and we'll start talk about what that all means and why it matters.